Hey, Flux here, and today I'm going to be working on something pretty neat. This is going to be inspired by someone called Stutters on YouTube, which I will be linking down below, but basically what we'll be making is...
Really nice. We're going to be making a fake snapper. It's
a fake snapper, as said in their own words. Now, we're going to be doing this a little bit different than Stutters did because we will be using dynamic bones and spatial variables. I do not have a problem, I am not addicted to spatial variables. Now, as a quick example of like what I'm even talking about, here is the example. So this little box here has this dynamic sphere on top. If I grab this and I move it over here and let go, it basically snaps to there. If I move it here, it snaps back to here. Now, the neat thing about that is that this is using no flux at all. I just grab this, I put it over here, I let go, it just works. Now, the way that this actually functions is very simple. First things first, we need the box, of course. So let's make a box, scale that down a bit, and we need the sphere. So let's make a sphere, scale it down a bit. Ignore the visual, it's not going to change because I'm not using it to scale the sphere. Then we select both of them to get rid of the edit visuals. Make the sphere actually a bit smaller, there we go. Now that we have this roughly in the right place, we just expect the cube, open it up, make it child. So we have this box child here. Select the sphere, open it up, grab the sphere, drop it onto the box child, and then we'll set the sphere's positions here to x equals 0, z equals 0, and y equals 1. Reset rotation, but we'll leave scale alone. Now that we have this, we'll go into the box here and also make the box not grabbable so we won't accidentally grab the box. And on the sphere, we'll just delete the grabbable entirely. Then we go to the box child here and set up the wiggly part. We'll go to physics, dynamic bones, dynamic bone chain, make sure the chain is grabbable, and just click set up from children. Now that we have this set up, we can actually just grab this and move it around like any dynamic bone that's grabbable. It's also a fun little toy. Now, once we have this, we have to actually make one more slot in the box, which is another box child here, which we'll call area. This will get a component called data, spatial, box variables, box constant value spatial variable, and the type is going to be float free. This is lowercase. We'll name the variable here rest spot because it's the spot that this object is going to rest at. And then we're simply going to be driving this value here with the position of the area so that if we move it over here, it actually updates the position based on that. Now, next I'm actually going to make the damping on this a bit lower and elasticity as well. So as we grab this, move it around, it's going to be wobbling a lot more. Then I'm just going to go to the sphere, make another child on the sphere itself, attach a component of type data, spatial samplers, and give this a, where is it? Value spatial variable driver of type float free, so that we can actually read the rest position. And we just grab the variable name and put that also into here, so we have rest spot. Now our default value is actually going to be the position of the sphere, so that is just 0, 1, 0. And we go to the sphere here, actually to the box child, go to the dynamic bone list, grab the original position of the sphere, and just drop that into the derive. So now, the original position here is 0, 1, 0. If we grab it and move it around, it's perfectly fine. However, if we grab this now and we move it over here, you can see that the original position updates. So when I let go here, it's now down there. And this will still have physics once I let go. Now you can see that there's a bit of a stutter as it passes into a new space. This is because the distance from center actually changes as the position here changes. We can try and fix it a bit by doing stuff like lowering stiffness. So now, for example, it's not as stiff as it moves. We can also change the global stretch ratio, for example, to move it around. Or up the max stretch ratio so it's allowed to stretch more. But at the end of the day, if there is some movement of the distance from the center, there is going to be that bit of like a hiccup. Now the neat thing about this is that not only can you just transition it between different points on the object, if we take this box child here and we'll duplicate it. Actually, this is the wrong box child. If we take the area here and duplicate it, and then delete the value copy, add another slot under here for our flux. Call this flux. We will grab, oh, not a light tip, we need a flux tip. We'll grab a reference to the area itself and a reference to the box because that's the space it's under. Then we'll go to browse nodes and get a transform, global transform. So then we can get the global transform of the area, go to conversion, and get a global point to local. So we can convert this global transform into a local transform for this slot. And that'll output currently the exact same value. Then we go to area and grab the value here that our constant value spatial variable is outputting. Make a drive for that. There we go. And now the final thing we need to do is just mark this all and pack it into the flux slot. Once we've done that, we can actually do something really fun. We can go ahead and select my hand, open it up, grab this area here and move it into the left hand, reset the rotation of the position, but leave the scale alone because it doesn't matter. Well, it does matter for the area sizing, so that's why you leave that alone. And now, not only can you put this on your hand, the moment your hand gets close to it, it'll just stick, as you can see. Now, you can change this behavior by changing the priority of the variables. So if you set this to 1, for example, it'll always override. But if you set it to -1 priority, now, actually, it'll keep sampling. Why? Why are you always sampling that? Live debugging, because I don't know why this is weird, right? Oh, wait, right, because this doesn't have an area, and this is just 0, right? So if we actually put it to an area, and we set it to 1, then it's going to overwrite. Sorry for the small hiccup, there we go. So now, if I put my hand close to it here, it'll stay on the area, but if I move it to here and I move my hand close, it'll stick to it. Or if I actually pick it up and I move it to my hand and let go, it'll also stick to it. And that's pretty much it. That's how you can make a fake snapper like this that even has a kind of like active reaction to it, so that instead of you having to grab it first, you can actually just make it attach. Yeah, I hope you enjoyed this, and I hope you figure out a use case for this, because I'm still trying to figure out what I can make with this that would be neater. By the way, since this changes the original position, this also will affect how far this can go away, so you can actually just take this off of the object entirely. Now, the cool part is, this isn't reparented. So this, technically speaking, while it moves with my hand, it's not parented to my hand. But yeah, I hope you enjoyed this video. See ya.